Welcome back to part 2 on how to contribute to RabbitMQ. My name is Gerhard. I am a staff software engineer at VMware, and in today's episode I help you place the last piece of the puzzle in a RabbitMQ contribution that has been ongoing since June 2019. The reason why it's been going on for so long is because the change had to happen in Erlang-OTP first, that's the runtime. Then we had to update the Prometheus Erlang library, which we did recently. And now it's up to you to do two things. First of all, add a couple of lines of code to the rabbitmq-prometheus plugin. That is the one that shows all the metrics or exposes all the metrics for RabbitMQ and Erlang in a Prometheus format. And then we will update the Erlang distribution dashboard, the one that we have open here, to show those metrics so we can visualize them. The end result will look like this. We have the Erlang distribution dashboard open in front of us. This panel here, data buffered in the distribution links queue, used to be blank. It didn't used to show any metrics. And we have it open here. It actually used to look like this. The name is different, but it's the same panel. We didn't have any metrics, and the reason why we didn't have any metrics is because we were waiting for Erlang-OTP to cut a release that exposes this metric. Then we had to update the Prometheus client library, and now we are doing the now we're doing the RabbitMQ-Prometheus change. So when we will be done with this, we will have a dashboard and a panel that looks like this. So what this is showing us is how much data is buffered in the connection that exists between two nodes. These are RabbitMQ nodes. They're also Erlang nodes. They're almost the same thing. And in a RabbitMQ cluster, every single RabbitMQ node communicates with every other RabbitMQ node using the Erlang distribution. When too much traffic is flowing through these connections, data gets buffered. And when data gets buffered, things start slowing down. So you may have experienced a RabbitMQ cluster that is slow to respond to commands. Maybe the RabbitMQ management takes a while to load. When that happens, typically it has to do with data getting buffered in the Erlang distribution channels, Erlang distribution links. And before that, you couldn't see that it was happening. With this panel, we will be able to see when we have reached the limit of the distribution buffer busy limit. It's actually ZDBBL. And if we hover over the eye of this panel, we can see what the default limit is in RabbitMQ, which is 128 megabytes. So once we reach this limit, everything stops. This buffer has to be cleared before more data can be pushed through it. You could increase this, but if you increase it, throughput may be faster for a while. Eventually it will still stop if it gets filled up, but latency will go up. So the bigger the buffer, the higher the latency in the system. We have a RabbitMQ tuning guide on the RabbitMQ website. That's a very good one to read. And the ZDBBL config in Erlang, which explains how this works from an Erlang perspective. So these are very good to read. But our contribution today will be to show how much data is buffered in these links. And you can see there's like the threshold, which is half of the default, 128 megabytes. And we can see that here we are hitting the maximum. And that corresponds to the data that's being sent to peer nodes increasing. By the way, this is something that we will run locally, and I'll show you how. So this is the deal. I will show you how to make this contribution, and it's up to you to contribute it. Contributing to RabbitMQ is not difficult. Some contributions are hard. Other contributions are easier. And I think this is an easy contribution that I will show you how to do. And I hope that one of you will contribute it. The contribution consists of 3 simple steps. We will add a few lines of Erlang, we will update this dashboard, and then we'll just open the pull request. Pretty simple. I think the process and looking at the process is the interesting part. So with that, let's talk about how does a contribution start. Every single contribution will start with an issue. So this was reported, as I said, on the RabbitMQ mailing list. Matt E did so, and we talked about it. We were saying March 25th, so about a month ago. And what I told Matt is, hey Matt, when this episode will be out on the 30th of April, which is tomorrow, it will show you how to contribute this pull request. So that's what I'm doing now. I'm actually recording the video to show how to do this. And my hope is that you'll be the one to contribute it. That would be pretty cool, I think. Let's take a look at maybe this one, OTP 2270. As I said, it was added on the 11th of June. Sorry, that's the wrong one. This is Prometheus Earl. No, I would like to take a look at this one, 2270. There it is. And these are the files. That's what I wanted. Okay, so this is the contribution. 3rd of June it was opened. This was what it looked like before, right? The missing panel, the one that we looked at earlier. We talked about the dashboard. This is what it looked like when we enabled the patch and we tested it, and this is what it was showing before. Obviously, it looks different now. And what else? Yes, this was the one that we settled on. We changed it slightly, so what we have today is very similar to this, and it was eventually merged. So merged. When was this merged? Let's see, merged, yeah, 18th of June. So very soon after it was opened. But that was not enough. We had to wait for an Erlang OTP release to be cut. And looking at the files, we can see here which versions of Erlang OTP contain this patch. So from 22.1 onwards, 22.2, 22.3, all these versions have this fix. Now, RabbitMQ, we had to cut a version that would support this version, this OTP version, and I think that was 3.7.23. Let's actually check that. RabbitMQ, which Erlang. So the first one was 3.7.15, and that was the first one that supported 22, and obviously everything in 3.8 supports 22. Now, our contribution, because it's rabbitmq-prometheus, that plugin only exists in 3.8. So 3.8, to be able to use this, your RabbitMQ deployment will need to use 22, because as we've seen, this feature only exists since OTP 22.1. So that's one of the requirements. Okay, now that we understand how all this fits together, let's go to creating a pull request, right? We've identified our issue, we know why we're doing it, we capture that in the issue. Let's start by writing a failing test. We have the RabbitMQ public umbrella cloned, and we are using the master branch. And in the public umbrella, when everything is set up, we are in the rabbitmq-prometheus directory, and we also have the master branch checked out. This is something that we covered in great detail in the previous episode, which is episode 3 from season 1. And that was the part 1 to how to contribute to RabbitMQ. So if you don't have this set up locally, now is a good time maybe to go back, watch that episode, and resume this one once those things are set up. This is the state of RabbitMQ-Prometheus right now. We have pinned the Prometheus Erlang client to version 4.5.0, and that's the one that does not have the metric that we're interested in. We want to see a failing test. And the failing test looks like this. We have specific Erlang metrics present test. This is what it looks like. We are checking that the response body, this is the response that comes from the RabbitMQ-Prometheus HTTP endpoint, includes this metric. The reason why we want to have a failing test is to make sure that when we do update the Prometheus client library version, we will have that metric. If we don't write this test and we don't know that it fails, we won't know when it's fixed or what exactly fixes it. So this is our check that the metric will be present, not just now, but also going forward in the future. So the instructions are captured in the commit. All of them are here. We want to remove the dependency, the Prometheus dependency. We want to run the tests, and then we want to take a look at the test output. So let's do that. Let's remove the Prometheus dependency. It's a directory. And let's run the tests, make tests. It will fetch the dependency and then it will run the tests. I already did that here, so I already had a previous run, and the test will fail like this. So what I can do now is open the test output, this one that I was running earlier, and let's see what fails. So first of all, let me back a little bit. This is the output from the common test, and it's the test framework that we use. It's an Erlang test framework. And we can see that in this run, we had a failure. We had two failures. There were 20 test cases in total. Most of them are okay, but these two failed. So let's click on this one and see what exactly failed. If we go to the bottom of the page, we will see that the line, no match. So this line was not present. And if we search for this, we will see in this green area, which is the output, which are all the metrics that are returned by the rabbitmq-prometheus plugin. And we can see that the only metric that we have is the Erlang VM dist node state. We are missing the Erlang VM dist node queue size bytes. To fix this test, let's go back here. Let's check out the version where we have fixed this. Basically check out master, where this pull request is merged. And we remove the Prometheus dependency and we run make tests again. That's it. So let's do that. Let's rm. Let's, first of all, let's make sure we check out, yes, the correct version. That's the one. And now let's run make tests. Okay, we can see that dependency is checked out with the right version, and we'll let it run. The tests are green, everything passes, everything looks good. We are ready to submit a pull request. Before we do that, there's something which I'd like to point out. The Erlang version which I'm running locally is 22.3.3, and as you will remember, this metric was introduced in Erlang 22.1. So make sure that your Erlang version that you're running locally is at least 22.1. Okay. With that said, we are ready to submit a pull request. I already did that. This is what it looks like. And there's a couple of things which I'd like to point out. First of all, I'm linking it to the issue which it fixes, which is 39. That is very important, especially for release notes, which I'll get towards the end of this video. The second thing is, what did we fix? And what does it look like if there is a visual element? Even though we haven't created this screenshot yet, we will do that next. The reason why we submitted this pull request early as a draft, and that is also important, is so that we run the checks. This is what they look like. For every single commit, you will see checks. So for the first one, they will have failed, but because I force pushed, you can't see them anymore. However, for these two, we can see that they passed. And the checks that run, they take maybe up to 5 minutes in this specific case to run, and they tell us whether the change that we've made is compatible with OTP, Erlang OTP 21.3, which is the minimum version that we support, and OTP 22.3, which is the maximum version that we support. And this again comes from rabbitmq.com, which Erlang. So the minimum version is 21.3, and the maximum is 22 something. And we recommend Erlang 22.x. It's a similar version which I had locally. So we just make sure that for both of them, the test passed. If you would like to see how these GitHub Actions are put together, what runs inside of them, what was the history, what passed, what failed, have a look. It's all in this GitHub repository, including the workflow configuration, literally everything. And if it's something that you will find useful for your Erlang project, you're more than welcome to copy it. Okay, the thing which I would like us to do now is run everything locally and capture observations. And what I mean by that is basically allow us to generate a screenshot which looks like this, that shows exactly what changed. To do that, we will take a look at the next step, which involves building a Docker image. This is a local one with the changes that we have just made. And we will bump this image across all the Docker Compose files that we have locally. And then we will not just start metrics, which is Grafana, Prometheus, CAdvisor, Node Exporter for containers, but we will also start a RabbitMQ workload, which is a 3-node RabbitMQ workload, which is using TLS. And we have perf-test putting moderate to high load, which is what we need to simulate the busy dist buffer. Okay, so let's do that. Let's run, first of all, make help to see what commands we have, what make targets there are. So the one that we want to run is Docker image build. And this one requires make test to run first, which we already have. And the alias for it is dib. And I always use the aliases, they're just easier to type. So this is going to be very quick in my case. The reason why that is because I already ran this before, so all the layers are cached. In your case, especially if Erlang, for example, has to be compiled, it can take a significant amount of time. 15 minutes, 20 minutes if you never ran this before. The Docker file that we use is at the top of the repository, so you can see it here, and it's based on the official RabbitMQ Docker image. So take a look at that if you're interested. So now that we have built and tagged a new RabbitMQ-Prometheus Docker image, which is RabbitMQ with a couple of extra things. So we are adding the local Prometheus client library, the local copy. It's the one that's used when we run the test as well. And we are also adding the local copy of the RabbitMQ-Prometheus plugin, and it's the one again that we're using for the test. So we know for a fact that everything works the way it should. The next step is to, again, let's just take a look at this. The next step is to Docker image bump. And Docker image bump is the diu. That's the alias. And what it will do, it will bump the image in the dist-tls Docker Compose file and the overview one and QQ. There are 3 Docker Compose files. Okay, now that we've done that, we will run make metrics. The alias is the alias is M for short. So make metrics, and all it does, it will start them. I already have them running, but nevertheless, I ran that command again. And the next thing that we want to run is dist-tls. And dist-tls, it just runs the Docker Compose files and it brings 4 containers up, actually 5. One other command which is useful, or one other make target which is useful, is ctop. And ctop will give you a top-like utility for containers. This is what it looks like. Make ctop not only will show me what is running, it just gives me CPU, memory, and I can see logs for different containers, so on and so forth. So this is everything that I have running locally. The 3 which we're interested in is Docker dist, the 3 RabbitMQ nodes, and the stress dist. This is, for some reason, it's failing, so let's take a look at that. Right, so what this means is that the RabbitMQ brokers took more than 30 seconds to restart. So I would like to restart this container, enter, start, or S, and yes. These 3 nodes took longer than 30 seconds, so that's maybe something that I would like to adjust in the Docker Compose file. Okay, all 3 containers are up. So the thing that I would like us to do next is go and take a look at Grafana, see what it looks like. Now that I think of it, I would like to double check the image that this container is using, make sure it's the right one. Yeah, unfortunately, we can't see all of that, which I would like to. So what's the easiest way? I suppose Docker PSA. This is another way to look at the containers. Docker exec, I would like to exec in this container, rabbitmq plugins list. Just make sure that it is running the correct rabbitmq-prometheus version. And there you go. It definitely is. It's running the custom one that we have just built locally. Nice. Okay, let's go to Grafana. Localhost 3000. This is exactly as it will present to you as well. So you won't be logged in. The password is admin and the user is admin. The user is admin, the password is admin, shall I say. I don't need to change it, it's just a local instance. These dashboards, because I visited them, they will be here, but in your case you won't see them. So you'll want to go to dashboards, manage, and the Erlang distribution one. And that's what it looks like. That is our Erlang distribution dashboard, which we can see it's getting metrics from all 3 nodes, but this panel is still not updated. And the reason why it's not updated is because we haven't modified the metric in the panel. So let's go edit or E, and let's replace this with, where is it? I thought I had it in my paste buffer. I'm looking for Erlang VM dist, that's the one, size bytes. And there we go. As soon as I updated the metric to the right value, we can see that the metrics were scraped correctly by Prometheus. They were already there, just Grafana wasn't looking at the right metrics. And now we can see them, now we can see the panel as it should look like. Okay, so if we come back, is there something else we would like to do to this panel? Yes. This is the old description, and we would like to replace it with a new description. You can see that it's referencing the pull request, and it looks slightly different from what I had here. So I had this running before. I obviously made the change already. So what I will do is I'll just copy it from here, right? It's the simplest thing. So I'll copy this one, drop it in here. I press E to edit. And with that, these look the same. There we go. Okay. There's one more thing which we need to do. We need to update the Erlang distribution dashboard, which is versioned in the repository. Because all that we've done, we've updated this in our browser, which is not even persisted anywhere. And we won't be able to save it. The reason why we won't be able to save it, because this is a dashboard that we mount into the container, so it can't be overwritten. We have it locally, we already have it versioned, so we want to get the change that we've made from Grafana, which is in the browser, into the file. So we do that by sharing the dashboard, export for sharing externally, save to file, and there it gets downloaded to my downloads folder. And then what I do a vim diff to see a side-by-side comparison of the local dashboard. So Docker, Grafana, dashboards, Erlang distribution JSON. This is the source of truth. And I'm comparing it to the downloaded one, downloads Erlang distribution. And we can see it side by side. Inside we have the source of truth, the local versioned Erlang distribution. And on the right-hand side, we have the one that we have just downloaded from Grafana. So the changes will flow right to left. The inputs change, we don't care about. That's something which gets templated. The flant status map panel, it's something which we have further down. The version of Grafana 6.7.2, as long as it's the same major, which is 6, it's okay. Data source, Prometheus, we had it like in a different part. The single stat panel is there, so that's another change, which is just an ordering thing, and everything else is the same. The iteration is something that we could change. It's just a timestamp, just Unix timestamp. So yeah, let's push that. Let's do diff put on this line, diff put, and we've made the change. To go to the next one, DS-Prometheus, we want to leave it null. That's just for local. That's something, again, that gets templated when we upload these dashboards, so null is fine for now. So let's keep going through these. Lots of DS-Prometheus changes. That's actually the first change that we want. And it's just after DS-Prometheus is the description for the graph that we updated. To push the change, we select a line, visual select, and then we div put. And that applies the change from right to left. The next change that we have is the expression, where we basically modify the metric. It's queue size bytes. This one we just div put, and that will get the change across. And with that, we are done. Everything else here we can leave as is. It's just data source. Those are really the only two changes which we wanted. So let's write this file, let's exit, and let's take a look at the diff. So the iteration changed, the description of the panel changed, and the metric changed. I think that is arguably the most important one, this one here. It's node queue size bytes. Okay. Obviously, we're going to commit this, and we can see that we've already done this here. So very similar. I didn't change the iteration, but it's a very similar commit. So we're going to use that one. And once we made this change, we have everything running locally. I think the more important thing is basically to capture, right, this change. So if you remember what I had here, so let's go closer to, it looked like this. There is a view mode, which we can use. We can also go like maybe for the last 30 minutes. And we can do a screenshot, there we go, of this specific thing. Control to keep it in the buffer. So if I was to add it here, I would paste the image, uploading image PNG, and when it will finish uploading, it will look like this. So this is our initial image, and this is the one that we just captured now. So I don't know which one you prefer. I think this one is nicer. I don't know, it's the recent one, so let's just keep it. Let's go to right. Let's just remove this initial one. There we go. If you update the comment, which is what I would expect you to do after you create the pull request and you waited for the checks to pass. You do a couple more commits, and then you make this screenshot, and then we have everything we need to mark the PR is ready for review. Right? This is it. This is what we've been building up to. So ready for review. I'm not going to click it because this is a demo PR. Do you know which PR should be reviewed and should be merged? Yours. That is the one that I'm looking forward to. So in order for that to happen, of course, you submit it, you make all the code changes, ready for review. It really helps to know who to ask for review. And to answer that, you need to know who is the code owner for the changes that you're proposing. To do that, you take a look at the files changed, and you'll see this icon next to every single file that was changed. And in this case, I am the code owner for the files in Docker. And metrics, we have no code owner for metrics, so that's interesting. And in test, it's me, but also Diana. It doesn't appear here, D Corbacho, it doesn't appear here, but that's okay. What you will do in the conversation is ask for review. I'm not going to ask for review for myself, that would be weird, but I will ask one from Diana. And when you select that, you can see that she will appear as a code owner. If someone that you're asking for review is a code owner, it's a lot, the review is more likely to be approved quickly because a code owner is a person that knows that part of the code base best, and that's why they own it, even though everybody can make this change on the team and they can approve the change. The code owners are the ones which have been there most recently, and they know that part of the code base best. So it does help to pick someone to review your PR that is a code owner. We can also see code owner of one file in this pull request. That is a nice feature. I'm going to remove Diana because this is a demo PR. I'm going to remove Diana from this PR. It's demo PR, we don't want her to actually review it. So if this is exactly where it should be, I think the next, oh yes, this is a really interesting one. So I'm sure that you will want to know which version of RabbitMQ to expect this PR in once it gets merged. And the answer to that is in the issue. So if we go back to the issue 39, the thing to look out for is a milestone. As you can see, this specific issue is tagged with milestone 385. And the reason why it's tagged with milestone 385 is because the state of the next release, which is 384. But for that, let's take a look at release notes. Release notes are stored in the RabbitMQ website, the site release notes path. And we can see we have release notes that go all the way to 357, 36, 37. The one that we are interested in is 384. And for 384, we already have RC1. Once we have release candidates, fixes are unlikely to go in unless they're security fixes or critical bug fixes. But once we cut a release candidate, it's most likely to land in the next minor. So, in the next patch. In this case, that's 385. So you know where to find release notes. You know that to know when a specific feature or issue will be addressed is by looking at the milestone and know how to link the two together. That is very important. That brings me to my last point, which is cleaning the local state. So as we were running here things, let's take a look at make ctop. We have a lot of containers running and we would like to stop them. To do that, there's a make down target. All it does is basically shuts everything down. Make down stops all the containers. And once we do this, the last thing remaining would be to maybe clean your local state. So I'm going to do that next. As these containers stop, I'll do git reset hard master. There we go, and head is there, head is at master, and actually git checkout master, that's what I want. Git checkout master, my branch is at the master right here, this is where I am, and then we have all these commits which are in the demo pull request. Which reminds me, I'm going to close this pull request because I would like you to do your own. To be honest, the branch will be there if you want to copy paste things, but I would really like one of you to contribute this change. And if you need help, you can take a look at this branch to see how it was done. Lastly, let's make sure that everything is down. It is. Make ctop. Everything is nice and clean. Nothing is running. Perfect. Only the ctop container. And with that, fail to fetch, that's okay, we don't mind. This is our contribution, and this is your contribution. So thank you very much for watching. I will see you next month.